Okay, so we're about to dive into an idea that is so big, so audacious, it honestly sounds like it's straight out of science fiction. It asks us to look up at the sky, something we think of as this constant, natural force, and ask a very simple but very radical question. What if we could do it better?
And there it is. That's the core proposal right there. And no, that's not from some sci-fi movie. It's the actual starting point for a pretty wild school of thought in atmospheric engineering. The idea here isn't just to change the weather, it's to tear down the whole system and build a new one from scratch. So what's the big idea behind this? Well, it's all about moving past what the folks behind this call atmospheric chaos. It's a way of thinking that looks at our sky not as some natural wonder, but as an inefficient, kind of buggy legacy system. Like an old, clunky operating system that's ready for a major upgrade.
And that really gets to the heart of it, right? What if we could engineer our weather with the precision of a Swiss watch? I mean, forget checking your weather app. Imagine a world where rain isn't just a chance, it's a scheduled event on your calendar. A world where the atmosphere just works for us with total mechanical predictability.
Okay, so before you can sell anyone on a radical new idea, you've got to tear down the old one. So let's explore the argument against our current system, the argument that the natural cloud is, from a pure engineering standpoint, basically obsolete tech. And this is where they really lay it all out. On one side, you have natural clouds. They're described as unpredictable, aesthetically chaotic. I mean, they look messy, they're all over the place, and just plain inefficient. But on the other side, the engineered solution, water cubes, precision, a clean, minimalist grid, total reliability. It's really the difference between a wild, overgrown forest and a perfectly controlled, high-tech hydroponic farm. All right, so you can't just propose something this wild without having a plan, right? So how exactly would we build this new atmosphere? Let's look at the blueprints for this new sky.
So the basic building block here has this very official-sounding name, isomorphic crystalline H2O structures. Now, this is not your average ice cube. We're talking about hyperdense, perfectly clear cubes, specifically engineered to be stable way up high. And the plan is to arrange them all in a fixed global grid they call the geolattice.
And the size of these things? Yeah, it's big. After a whole lot of modeling, the proposal landed on the perfect size for each cube, 1.5 cubic kilometers. That apparently is the sweet spot for keeping the atmosphere stable and, as we're about to see, for bending light in very specific ways. And the plan to get them up there? Oh, it's just a simple four-step process. First, you flash freeze super pure ocean water in factories orbiting the Earth. Then you just launch these giant cubes into a perfect fixed position. Third, you turn on some magnetic fields to lock them into the grid. And finally, you send out a bunch of drones to keep them polished. Yeah, simple. Okay, so that's the how. But what about the so what? Let's bring this whole idea down to earth for a minute. What would it actually feel like to live under this perfect crystal grid? How would our day-to-day lives really change? And this table really breaks it down, the before and after of this whole thing. Your weather forecast is no longer a guess, it's a schedule, down to the second. Flying, no more turbulence or weather delays, ever. Photography, perfect, consistent light all day, every day. And farming, well, you can say goodbye to droughts and floods. It's all just automated, targeted watering from the sky. A world of pure efficiency. But, with any grand plan, there are always some unexpected side effects. With no clouds to scatter the sunlight, the sky would be brilliantly, blindingly clear all the time. The predicted economic result? A massive boom in the global sunglasses market. A small price to pay for perfection, I guess. But all this talk of efficiency and predictability brings up a bigger question, something a little more poetic. If you get rid of the random, messy canvas of the clouds and replace it with a perfect, motionless grid, what on earth happens to a sunset? And the proposal's answer is, you don't lose it, you perfect it. You turn it from a beautiful, random accident of nature into what could be the single greatest work of performance art in all of human history. See, the secret is that these cubes aren't just blocks of ice. They're gigantic, flawless crystals. So light doesn't just pass through them. It can be controlled with absolute precision. Sunsets would stop being a random event. They'd become a daily, globally synchronized light show. So here's how it would actually play out. Every single cube would act like a massive prism, splitting sunlight into this perfect, predictable rainbow. Then the entire grid, the whole geolattice, would bend that light all at once, based on a pre-programmed schedule. So every evening, at the exact same time, every single person on Earth sees the exact same perfect sunset. Wild.
And that's really what it all comes down to, isn't it? This proposal makes the case that a perfect sky is possible, a sky without randomness, without uncertainty. We could build the perfect sky, but the real question is, would we miss the beautiful chaos of the one we have now?